This video documents the scale model testing of our latest design, XSV20.
Testing comprised of static and slow-speed instrumented tank tests, as well as high-speed dynamic and resistance tests, carried out by towing the models alongside a rib. This allowed us to tow the model in a manner designed to give relatively free movement, but also constrain its course. As such, we were able to tow the model for long durations over a 2-mile course, enabling us to observe its seakeeping and handling at close hand, as well as accurately video document the trial for later analysis. This way we were able to get a very good feel for the way it performed in a wide range of conditions and speed. During the development stage, some 12 different models were built. This allowed us to experiment with different configurations of the design, including hydrofoil versions and ultimately the chosen stepped hull design, which proved complex, necessitating 5 separate models to determine the correct step size, placement and configuration in order to achieve the optimum performance by reducing drag and resistance, yet maintaining high-speed dynamic stability. To allow us to visualize water flow and separation across the steps and within the tunnel, a version with a clear bottom was tested. We build the models at a scale of 14:1, lofted from 3D hull software used in the design of XSV20 and built by hand ourselves.
We also undertook tank testing on the design.
We're at the Murray facilities, which is part of the University College Cork. Here we've been able to carry out a variety of tests in a range of different sea states, including some pretty extreme simulated survival waves. The tank can generate a 1 meter breaking wave, which is the equivalent of a 14 meter wave in real-life scale. This allowed us to benchmark XSV20 against traditional hull designs. Sensors are attached to the models, enabling us to measure motions such as roll, pitch and yaw. We were also able to tow 2 versions alongside each other. This enabled us to determine the characteristics of different versions in identical conditions of speed and sea state. A digital scale was attached to the towing bridle, which allowed us to record the tow force at different speeds. The models were tested at scale tow speeds of up to 35 knots, equating to real-life speeds of over 125 knots. It also allowed us to benchmark the design against other hull forms, which clearly demonstrated its superior seakeeping in many respects. During testing, the models were pushed to the very limit, allowing us to ensure the final production version performed perfectly, even at speeds and in sea states well beyond its maximum operational envelope.